Okay. Hi guys, we're looking at problem number 41 in this video. Now 41 is going to be a little bit different than 39 and 40 because this one is not at equilibrium. It gives us the initial and then it talks about after equilibrium is reached. So I'm going to go ahead and write the equation first. SO2 plus NO2 here goes to form SO3 plus NO. Now, in this case, it wants us to calculate the K, so we don't know that. But I can go ahead and set up my equilibrium expression. Again, our products over our reactants. We don't have any coefficients, so it can just simply be SO3 times our NO over our SO2 times our NO2. Now, in this, remember, we want to use concentrations, or again, if we were given a gaseous state, we could use the atmosphere as the partial pressures here. But what these have done is it's given us moles. Now what's nice here is that it tells us that they're all in a 1 liter flask. So to do the molarity, again that's moles per liter, since it's all in a 1 liter flask, the moles that they give us, if you divide that by 1, you end up with moles per liter, and anything divided by 1 is going to be what the moles were. So it tells us that we have 2 moles of the SO2, well, it's in 1 liter, so I'm going to say that we have the 2.00 molar is this guy, and 2.00 molar for the NO2 as well. Now, it does tell us that after equilibrium was reached, it was found that 1.30 mole of gaseous of the NO2 was present there, okay? So initially, we had 0 of each of those. And it tells us then that after equilibrium was reached, I had 1.30 moles, and again, since it's in 1 liter, it's going to be molar, of this. Now, if I look, everything is at a 1-to-1 mole ratio. So in saying that that's at a 1-to-1 mole ratio, I know that there's 1.30 moles of this one made, so I also know that there's 1.30 moles, or molarity, excuse me, of molar of the SO3. What I also know is what I create here has come from this side. So where this was really like a plus 1.30, we're going to subtract, and this is for the change, the 1.30 from each of these. Now again, it's because the reactants are losing what the products are gaining. So in looking at this, at our equilibrium here, we're going to have 0.70 for this, 0.70 for the NO2, 1.30 and 1.30, and again, I'm looking at molarity here, so I'm just going to kind of ignore those units there. And so when I want to find my K, all I'm going to do is I'm going to plug these numbers into that expression up there. So my K equals my SO3, which is my 1.30, times my NO, which is also 1.3, divided by my SO2, which is 0.70, times my NO2, which is also 0.70. So when you take this 1.30 and essentially square it, divide it by the 0.70, basically squared here, and I forgot to write down my answer, so let me go ahead and work that out. You get your K to be equal to 3.45. And remember, K is unitless, so you just can simply go ahead and put the K. All right. I'm going to maybe try here on this video. I hope it doesn't come back to bite me. And I'm going to try 43. Put a little divider line here. So hopefully this will all go on one video here. Okay, so 43 is another one that is not at equilibrium. So they're going to give us the initial amounts here. And this one is going to be a little bit harder than 41 because they do have coefficients. So it tells me I have 2 SO3 is in equilibrium, white mouse here, with 2 of the SO2 and O2. So if you read 43, it tells us that we have 12 moles of the SO3, but that is in a 3.0 liter. So I'm going to take and put these into concentrations. So I do have 12.0 moles of the SO3, but that is in 3.0 liters. And of course, if you take 12 divided by 3, you get 4 is your molar here for this guy. And it does also tell me here that at equilibrium that the SO2 has 3.00 moles. So what I'm going to do is I'm going to take that 3.00 moles of the SO2 and put that over the 3.0 liters. And that, of course, is going to be then at 1.0 molar. And that's going to be after equilibrium. Okay? So it says that this one is initially here. So I have 0 of this, 0 of this. And at equilibrium, I'm going to have 1.0 molar of that. Now, what you will notice is that this, everything is not a 1-to-1 mole ratio. So I cannot do just as simply as I did in 41 and just subtract the 1.30. What I look at is that this is 2. So the 2 in front of this means that this is a 1 to 2. So this is going to be half as much of this. So your O2, you start off with you end with, at equilibrium, 0.5 molar. Okay? Now the SO3 is going to lose it. If the SO3 has a coefficient of 1, it would be the same as the O2. But because it has a coefficient of 2, it's going to go ahead and be the same as the SO2. So I'm going to, so this is our initial up here. Here's our change. We're going to minus the 1.0 from over here. So when I'm doing this for our equilibrium,